Hello, so welcome to this video. When we talk of covalent bonding, so when we talk of covalent bonding, okay, we mean it's the bonding that occurs between non-metals only, right? Non-metals only, and this involves the sharing, okay, the share of what electrons. Since they are all non-metals, they can't transfer electrons, but they can only share electrons. Remember, non-metals they gain electrons. Sorry. Let's look at an example. Let's say hydrogen, which has got this. It's a compound made of two hydrogen atoms. All right. How can we write the valence electron shells of this bonding? Now remember, hydrogen, for it to be stable, it needs two electrons, right, to be stable. So we know that if we make this shell, right, and this other shell, you put hydrogen there, you put hydrogen. Remember, you have this hydrogen here, you have this hydrogen here. It's like that, and it's like that. This is what hydrogen is. Now we only consider electrons here. Since we have one electron here and one electron here, for hydrogen to be stable, it needs two electrons. So let's say if this hydrogen donates one electron, yes, it becomes there. It means there's nothing here. And this one also, since this one has donated to here on the center, this one must also donate. Comes like that. Now you can count that this hydrogen just alone here, it's stable because it has two. Also the other hydrogen here, it's stable because it has two. Now let's look at carbon dioxide. How can you write the display formula of this covalent compound? Now we have one carbon. Since we have one carbon and two oxygen, the carbon will be at the center. Alright? Since the carbon will be at the center, two oxygen, one will be here and the other one will be here. So say oxygen, carbon. Now we know that oxygen this side, it is 2,6. Alright? Remember, even the other oxygen here, it's 2,6. Or carbon, it's 2,4. Remember, carbon is like this on the periodic table. Sorry, it's like this. Or oxygen is like this. So when you write the electronic configuration of oxygen, you are finding this and also this one. And for carbon is this. So now these, they have to donate electrons. Now remember, this is oxygen, carbon. For them to be stable, they need 8 electrons in the outer shell. So let's say this one donates 1 electron at the center there, right? Because this one has donated to the at the center, even the carbon must donate. Let me use this. Therefore, what we have here, it's 5, and what we have here is 3, right? Now, because carbon is at the center, it has to donate also this side. All right, that. So instead of having 3 here, we have what? 2. Now, because this one also donated, also this one must donate like that. So we have 5 there instead of 6. Now we have 5 electrons. The outer shell has 5. The outer shell has 2. The outer shell has what? 5. 5 plus 2, it's 7. They are not stable. They must be 8. 4 plus 2, that's 6. They are not stable. So for them to be stable, remember they must have 8 in the outer shell. So this oxygen donates another one. Since the oxygen had donated, even the carbon must donate. So I can tell that here there's what? We have 4, we have 1. Therefore, this one should also donate. Since it had donated on the other side, it should also donate this side. Okay, like that. That means it has remained 0 there. Since the carbon has donated, also this one must donate. So we have that. So we have 4 there. Okay, now count. So we have 1, 2, 3, 4, which is this one. Here we have 0, so we can't put anything there. Here we have 4, 1, 2, 3, 4. You can count 1, 2, 3, 4, 5, 6, 7, 8. It's stable. 1, 2, 3, 4, 5, 6, 7, 8 is stable. 1, 2, 3, 4, 5, 6, 7, 8 is stable.